Hi, we're going to solve example 2 in section 5.1 of the book. And it looks something like this. Solve the system by graphing. And this is the system of equation that it refers to. And here's our graphing application. This, for those of you who are interested, this is something called Geometer Sketchpad. Useful sort of thing when you want to graph things. All right, back to our system of equation. We have two linear equations. All right. This one we know is linear because it's in standard form of a linear equation. This one we could very easily change in a standard form. So they're both linear. Since they're both lines, we know that all we have to do is calculate 2 points. And of course, the easiest points to calculate are the intercepts. Why? Because intercepts involve arithmetic with 0, and 0 is really easy to do arithmetic. So, let's start with equation 1. Plot 2 points. What is equation 1? Y equals minus 2x plus 4. So the first thing I'm going to do, because I got to start somewhere, let me calculate the y-intercept. How do I do that? Pretty easy. I just let x equal 0 and see what happens to y. So I have y equals minus, plug in a 0 there, plus 4. Oh my, this is just too easy. My 0 goes away. Y becomes 4. So I already have one point. It's, well, what did I do? I assumed x equals 0, so x is 0, and y becomes 4. So that's my first point. I plot that, and of course it is, in fact, the y-intercept. Here's the y-axis running up and down here vertically, and that's the point 0, 4. All right. We're going to do this variation on this theme. We're now going to calculate the x-intercept. And how do we do that? Easily. Now we're going to let y equal 0. When we let y equal 0, well, what happens? I plug it into this equation, and I get 0 equals minus x plus 4. All right, subtract 4 from both sides. And what do I get? That goes away because that's 0. So now I have minus x equals minus 4. Well, I'm going to multiply both sides by minus 1. That's going to get rid of the negative sign on the left-hand side. Minus 1 times minus x is just x. Minus 1 times minus 4 is 4. So I have my second point. 0. Nope, not 0. I have this fascination with 0. X is 4. Being an Egypt here. So, x is 4. What is y? Well, we started out with the assumption that y is 0. And when y is 0, x equals 4. So we have our second point. 4, 0. And in fact, it is the x-intercept because this is the x-axis. And when we plot our line, guess what? The line crosses the x-axis at the point 4, 0. So we have one line plotted. Let's plot the second line. Well, first we've got to remember what the second line is. What is the second line? It's this guy. 2x minus y equals minus 1. Okay. 2x minus y equals minus 1. Let's just double check. 2x minus y equals minus 1. Okay. So now we want to get two intercepts for that, and we'll do the same thing we just did. Let, before we do the let stuff, what are we going to do? We're going to calculate the y-intercept. We could have calculated the x-intercept first. Doesn't really matter where we start. So let x equal 0. So I get 2 times 0 equals minus y. Oops, no. So I get 2 times 0 minus y equals minus 1. Again, this is like so easy. Minus y equals minus 1. Same trick. I'm going to multiply both sides by minus 1. So now I get y equals minus 1. Alright, so x is 0, and y is plus 1. Minus times a minus. That's plus 1. So I plot that. And just as I said, this is the y-intercept. Here's the y-axis, and it's right on it. So whatever our line looks like, it's going to, in fact, cross that point. All right, now we have to calculate the x-intercept. And we do that by letting y equal 0. And we plug it into our favorite equation here. Well, it's favorite for now. So I get 2x minus 0 equals minus 1. Well, that's good. So now I have 2x equals minus 1. Get rid of the 2 by division. Divide both sides by 2. That becomes 1. 1 times x is x. So x equals minus a half. And what's y? Oops. Again, I have this fascination with 0 here. But I have to be careful. My x-coordinate is minus a half. My y-coordinate is 0. Alright, so I plot that point. And I connect the dots. Now, look what happens. They intersect right there. And where is right there? Because that's going to be the solution. Well, x is 1 over, so x is going to be 1, and y is going to be 1, 2, 3. So our solution is 1, 3. Now, since we know how to check a solution, we would be foolish not to check. So let's check our solution to see that, in fact, the ordered pair 1, 3 is, in fact, correct. So let's paste in here's our system equation. So we're going to check that. And of course, our solution is 1, 3. Alright, so we're going to check that. So we got 1, 3. So what happens? Let's look at equation 1. See if that works. So equation 1, we're going to let x equal 1 and y equal 3. Alright, so when we plug it into this equation here, what do I get? I get 3 equals minus 1 plus 4. The question is that true? Is 3 equal to minus 1? Well, of course, minus 1 plus 4 is 3. So that's true. Well, so good, so good. Let's check the second equation. That's this guy here. And so now we're going to have 2 times 1 minus, what's y? Y is 3. And the question is, does that equal minus 1? 2 times 1 is just 2 minus 3. Well, that equals minus 1, which equals minus 1. This is true. So 2, 3 is a solution. I'm sorry, the ordered pair 1, 3 is a solution. And as always, if you followed that, or even if you didn't follow it, you should try to this problem, which is example 2 in the book. If you don't understand it, the solution that Ms. Messerschmidt gives is nicely detailed. She does it in a slightly different way than me. Perhaps it's more elucidating. In any case, I wish you best of luck. Bye now.